Okay, we're going to jump into lesson 22.3, which is on the triangle inequality theorem. So let's start by taking a look at what the theorem says. And it says that the sum of any two side lengths of a triangle is greater than the third side length. Okay, so one more time, that's if I add up any two side lengths, it needs to be greater than the length of the remaining side. All right. You can see that they've given you some examples here, right? So if I add up the length of AB and BC, it needs to be greater than this remaining side length here in order for us to make a triangle here. In this first example, it says use the triangle inequality theorem to tell whether a triangle can have sides with the given lengths and then explain. And we'll use that theorem here. And there's basically three criteria here. So if I take 4 plus 8, that's two of my side lengths. It needs to be greater than the remaining side length. Okay, I'm going to put a little question mark there. All right, so that's the first option. And then if I do 4 plus 10, it needs to be greater than 8. And then lastly, if I do 8 plus 10, it needs to be greater than 4. And so for this one, it's pretty simple, right? We can check it pretty quickly, but this is the criteria that we need to create a triangle, or else the sides wouldn't be able to create a triangle. Like you can picture, it would be like if one of the sides was too short and wasn't connected to the other side. And so we'll check this real quick. This gives me 12 is greater than 10, and that's a check mark. Okay, and then here we've got 14 is greater than 8. And that's true as well, so that's a check mark. And then we go to 18 is greater than 4, right? And that's a true statement as well. So this one checks out. So this one would be a triangle. Okay, so this would be, these three sides would be able to create a triangle because it satisfies that triangle inequality theorem. All right. If we go down to the next one here, okay, same thing. We're going to set this up. So I'm going to say, okay, well, 7 plus 9 has to be greater than 18. So we'll check that one. And then we've got 7 plus 18 has got to be greater than 9. And then lastly, we've got 9 plus 18 has got to be greater than 7. And then each one of these has to be true, or else we won't have a triangle. So for this one, we've got 7 plus 9 gives me 16. And is that greater than 18? And we can see right away that this is not going to work. So this is an X. Okay, so then this is not going to be able to create a triangle. So I'm going to put no. These sides would not create a triangle. One of them would come up short, and we would kind of end up with a triangle that looked something like this here. Right, where it was missing that final piece. Okay, so it wouldn't be able to create that triangle. So as soon as one of them isn't true, right, in this case, 16 is not greater than 18. As soon as we get that, then we know that this is not going to be able to create a triangle. Let's go to letter C. Same idea here. We're going to start by setting up my inequalities. 5 plus 5 has got to be greater than 10. Okay, and then we would end up with 5 plus 10 is greater than 5. And then the last one is going to be the same, right? Because we've got two of the same numbers. So I don't have to write the final one here, but we can go ahead and check these. This turns out to be 10 is greater than 10. And we have to ask ourselves, is 10 greater than 10, right? It's not greater than or equal to, it's just greater than. And in this case, it's not, right? Because it's equal to. So this is a no. It has to actually be bigger than 10. Okay, so this is going to be a no, so this does not work. And once again, this would not be able to create a triangle. We'd come up just short if we were drawing our triangle here. Okay, so it's going to be no. And that's because it has to be greater than. Okay, it can't just be equal to it. All right, we'll keep moving here. It says find the range of values for x using the triangle inequality theorem. So I'm going to set up the same scenario as before, right? I know that if I take, let's see, if I do 12 plus x, that has to be greater than 10. Okay. So that's option 1. All right. And then if I take, let's see, 10 plus 12 has to be greater than x. That's the other option. Okay, and then lastly here, the remaining combination would be 10 plus x has to be greater than 12. Okay, so those are the three scenarios, right? Two of the sides got to be greater than the remaining side. And so then I'm going to go ahead and simplify these, and we're going to come up with a range of values for x here. So this first one here, I would subtract 12. Okay, and I would end up with x has to be greater than negative 2. Over here, we're going to end up with, let's see, 22 is greater than x. Okay, the other way I could write that is that x is less than 22, right? Those are the same things there. And then over here, I would subtract 10 and end up with x is greater than 2. Okay, so we've got a bunch of different constraints here, right? The first one that I noticed right off the bat is that we've got x greater than a negative number. Okay, when we're talking about side lengths, negative numbers don't really make sense, right? Because we can't have a negative side length. Okay, so this one's probably just going to get eliminated because it's a negative number there. So let's look at the other constraints that I have. One of them is that x has to be less than 22, right? And then I also know that x has to be greater than 2, and that's from this constraint here. So x has to be greater than 2, and I'm going to write that as a compound inequality. Maybe you remember those from a couple of units ago. Okay, and so this would be the range of outcomes. Basically, I'm saying that x has to be in between 22 and 2 because it needs to be less than 22, greater than 2. If it's a number in this range, then I will be able to have a triangle. And if it's not, then these sides would not connect and it would not satisfy the triangle inequality theorem. And let's do that one more time here. Okay, so set up the scenarios. First, it would be that x plus 15 has got to be greater than 15. And then we would end up with the other scenario, which is that 15 plus 15 has got to be greater than x. And then the last scenario would be the same as the first scenario because it's just another 15 plus x is greater than 15, so I don't need to write that one down. I'll go ahead and simplify these. So start by subtracting 15. So I've got x is greater than 0. And then over here I got 30 is greater than x. I can rearrange that so it says x is less than 30, right? Flip that around. And so I end up with these two scenarios here where x has to be less than 30 but greater than 0, so somewhere in between there. And if x is in between 30 and 0, then I will be able to build my triangle. All right, we'll keep going here. And the next one, we've got another statement that says this is a side angle relationships in triangles, and it says if two sides of a triangle are not congruent, then the larger angle is opposite the longer side. So basically what this is saying here is that if I've got, I'm going to jump into this next example, if I've got the largest side in this case is 15, it'll always be opposite the largest angle. Okay, and so that means I know for this triangle, the largest angle is going to be B. All right, and then if I've got the smallest side, which is 10, it's going to be opposite the smallest angle, right? And then 12 would be right in the middle. So my example is saying for the triangle, order its angle measures from least to greatest. So first I'm going to identify the smallest side length, which is 10. Okay, that means at the smallest angle, the least angle is going to be opposite that. So angle C is the smallest. All right. And then next biggest would be 12, right? And 12 corresponds with angle A. So angle A is the next smallest. And then the largest is going to be angle B. And that's because it is opposite the largest side length. Okay. And then we can also say that goes vice versa, right? So it says if two angles of a triangle are not congruent, then the longer side is opposite the larger angle. So for this one, it says for the triangle, order its side lengths from least to greatest. So it wants me to talk about side lengths now. Well, I know that the shortest side is going to be opposite the smallest angle. So here's my smallest angle, and the opposite side there is going to be CB. So that's the shortest side. Then I go to the next smallest angle, which is 50. And that's opposite of this side, AB. And then the largest angle is 100, and that's across from AC. All right, thanks for watching.